So what we are going to be doing today, so our dynamics unit lesson 1, F equals m times a. This is Newton's second law. So after we finish this one, we're going to do number 1 and number 3 as well. So Newton has 3 laws. Today we're doing number 2. Okay? So his second law of motion is the formula F equals m times a. Now, can you find it in your formula sheet? The formulas we are looking at now are under the dynamics heading. Okay, dynamics. So it should be that first one, except it's structured as A equals F net over M. Can you find that one? A equals F net over M. Okay. So keep in mind that F net is important because it means the overall. So where it says net, net means like the overall, what you end up with. Okay, that's what net means. So that's on your formula sheet. So as we have already discussed, dynamics is the study of why objects move. Whereas kinematics was the study of how the objects move. So if they're accelerating, slowing down, whatever. Now, how this happens is a force, which is a push or a pull. This is always, always measured in newtons. You need to remember that. You'll experience throughout this whole unit, we're going to be looking at lots of different types of forces. So whether it's the force of gravity, the force of tension, the force of, I don't know, whatever, it's always measured in newtons. So no matter what force, it's measured in newtons. So it is a vector quantity. It has both direction and magnitude. So a net force, as I just had said, net force, where we have the F and the arrow, net, is defined as the sum or total of all forces acting on an object at one time. So like when we had our tug-of-war, if it wasn't moving, it was because the force pulling this way equaled the force pulling this way. Since it's a vector quantity, it would be like this one is a positive and this one is a negative. So it would be like positive 5 newtons plus negative 5 newtons equals 0. So then it didn't move. So the net force was 0 because the tug-of-war rope didn't move. But an unbalanced net force acting on an object will cause the object to accelerate or decelerate. So when our force on our tug-of-war wasn't equal, the girls slid this way and so they accelerated. Okay? Therefore, an unbalanced force will cause an object to experience a change in velocity. So this, remember, a change in velocity means acceleration. A change in velocity means acceleration. Now it can be, a change in velocity can mean just a change in direction, okay, which can be acceleration too. So anyways, as we've said on our data sheet, we have A is equal to F net over M. So it's on our data sheet like that, but often people will write it just like F net equals M times A. That's often how it's described with Newton's laws, because he talks about forces. So in this equation, F net is the net force acting, M is the mass, and it's always in kilograms. Very important. Really, really important. So if your question gives it to you in grams, you need to convert it. And A is in meters per second. Again, force is in newtons. Really important that you make sure you got those down. So a balanced net force occurs when an object experiences no acceleration and is either moving at a constant speed or is at rest. this above, this whole formula is known as Newton's second law of motion. Now, did you notice here that it says an object that has balanced net force, they just are experiencing no acceleration. But that means that they could be moving or at rest. So, and this will apply when we talk about Newton's first law, because an object in motion will stay in motion unless acted upon, and an object will stay at rest unless a force is acted upon it. So your F net could theoretically, an F net could be 0, but an object could still be moving. So, I don't know how else to say it. Maybe I'll just explain it more when we get to another example. But just keep in mind, there could be a net force of 0, but an object could still be moving. They're just moving at a constant speed. There's no change in velocity. Now, if we look at the formula, we can look at the variables and describe their relationship. So when we talk about the change in velocity, and we look at, that's acceleration, so when we look at acceleration, and compare it to the net force, so acceleration and net force, they're inversely proportional to the object's mass. So that's just another way of explaining that it's A equals F net over M. Okay? Now, when it's proportional, as the manipulated variable changes, the responding variable changes the same way. That's what proportional means. So if, I don't have a different example in mind. If I eat more chocolate bars, I will get fatter. You know, like they're proportional. How many chocolate bars I eat is proportional to me gaining weight. Okay? That's what proportional means. As one increases, the other increases too. Okay? So we can describe, compared to A and F, we say A is proportional to F. So that's A is proportional. That's what that symbol means. Have you guys seen that before? No? Okay, so that symbol means proportional to F. So that means as A increases, F will also increase. So the proportional sign, the F kind of got messed up. Sorry. So it's proportional. So it would be like me eating chocolate bars is proportional to me getting fat. A is proportional to F. Okay? So when we represent this, blah, 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 because how do I know this? Well, if A is equal to F net over M, if I take away the factor of M and I just want to compare A and F, I'm going to say therefore, that's what 3 dots in a triangle means, therefore, A is proportional to F net. So if I just kind of take away my M, because I just want to look at what is the relationship between two variables. So if I change A, I'm just going to, can I erase this? Just to have room. So on my little graph, oh, sorry. Is this on your side? Is this like that?
Yes.
Just put if mass is constant. It kind of missed that there. If mass is constant, that's what it's saying. So if I keep mass the same, and I change my A, okay, or if my A is my response, sorry, meters per second squared, F net is in newtons. So if I increase F net, my A will increase. So you will get a relationship that looks linear. You get a linear relationship. And this is because, we don't really have much space here, do we? No, never mind. No, I should tell you. I'm just going to write it here, wherever you have space left. This is because A is proportional to F net is similar to y equals x. So a linear shape on a graph is y is proportional to x. Okay, have you done that yet in math? Are you guys in math this semester? Okay, you'll do it
last year.
Okay, good. So that's why they'll have a linear relationship, is because they're directly proportional. Now, comparatively, inversely proportional means that when one increases, the other decreases. So the more carrots I eat, the less fat I get. So one increased, the other decreased. Okay? So when we look at just A compared to M, we say A, well, if I just look at my formula, A equals F net over M. If I just want to look at the relationship between A and M, so I set F net to 1 because it's constant. So I say A is then proportional to 1 over M. So it's 1 divided by M. So it's inversely proportional. So a graph that looks inversely proportional will look like this. So if you put your mass here in kilograms and your A in meters per second squared, they won't be linear, okay? If they're inversely proportional, an inversely proportional graph, I like your mouse, looks like that. You still have to pay attention. Very important. Okay, so because A being inversely proportional to M is similar to y equals 1 over x. Okay, and that's an inversely proportional relationship.